Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So today we will discuss some Java language fundamentals in the session 3. And let me give you the outline of today's lecture. What exactly we are going to discuss. So we will be discussing keywords that are used in Java, primitive data types used in Java, operators used in Java, which are mostly similar to what we were using in C++. So there is no much difference compared to C++ and Java. Most of the operators are as it is. Okay, just a few more operators like instance of operator. This is something new which we use only in Java, not in C++. After operators, we will discuss what are variables and what are literals. Okay, this is the outline of today's lecture. These topics we are going to discuss one by one. So keep your notebooks ready. Whatever which is not written in the PPT and I will be speaking, you can note down in your notebook. So what are keywords in general? What do you understand by keywords if you have learned any programming language?
Reserve words.
Reserved words which are used for some specific purpose, and that is the reason why we cannot use these names for naming any variable. Suppose I am declaring any variable, I am declaring any class, I am declaring any method, I can give it any type of name, but I cannot name them with the keywords. For example, suppose you kept one pet, you brought one dog from the market. Will you name that dog as New Delhi?
No.
Is there anyone who would like to keep their dog's name as New Delhi?
No, ma'am.
No,
No, ma'am.
because New Delhi is the capital of India. So in general, what we know is New Delhi is the capital of India. It is reserved for that purpose. It's a name of a union territory. So we would never like to keep anyone's name as New Delhi. Like none of your classmates will be having the name New Delhi, Pune, Chandigarh, Mumbai. Such names we don't keep. So similarly, in the programming language also, we don't keep keywords as identifier names. What are identifiers? When we are trying to name any variable, class, or method, or interface. So these words which are reserved, which have some predefined meaning, are known as keywords. Now the question comes, how many keywords do we have in Java? So if they ask you in the interview, how many keywords do we have in Java? You have to say we have total of 52 keywords. Please note down, we have total number of 52 keywords in Java programming language. Out of these 52 keywords, 2 keywords are not in use. Okay. So now the next question that comes from the interviewer will be, what are those 2 keywords which are reserved but they are not used? We have 52 total keywords, but out of those 52 total keywords, 2 keywords we are not using. What are those 2 keywords? So you have to note down in your notebook. First keyword is go to. Go to, G-O-T-O, go to. See, it has been underlined here. Can you see? Go to. Asterisk. So go to is a keyword, but we don't use this keyword in Java language. Next keyword, which is a reserved word, but we don't use in Java, is const. C-O-N-S-T. Const. Do we have const in this table?
Yes.
Where is it? I can't find.
Yes, ma'am.
First column.
First column, last one. First column, last row.
Yes, this is const. Okay, so const and goto we don't use in Java. Okay, why we don't use? Because goto statement is not encouraged in any programming language because of its complexity. Okay, if you are using goto statements in the program, the flow control will become very messy. So it is not advised to use goto. And why don't we use const? Because for declaring constant values in Java language, we have another keyword called as final. Can you see the final keyword? We use final keyword for declaring constants in Java. That is the reason we don't require const. So number of total keywords in Java 52. Which two keywords are not used? Goto and const. Okay, that are the only questions that you can expect from the interview point of view from this topic. So this topic is not very complicated. What are keywords? We already know. Shall we proceed?
Yes, ma'am.
Yes.
Yes, ma'am.
So have a look. Keywords are reserved identifiers that are predefined in any programming language and cannot be used to denote other entities. For example, class, Boolean, abstract, do, try, etc. Incorrect usage results in compilation errors. That means if you try to create a class with a keyword classy, so definitely it is not going to create a class for you because the keyword that we have for creating a class is class. It's not classy. So no spelling mistakes are allowed while you are using any keyword. Whereas if there is some variable, let's say Ritu, you want to create a variable with the name Ritu in Java. Now, while I am declaring a variable with the name Ritu, I can make some spelling mistakes also. I can make Ritu as Riti. It's a variable, it doesn't matter. Be it Ritu, be it Riti. It's a variable name. We can commit some mistakes. But if you are using keywords, you cannot commit any mistake. It has to be the way it is. In addition, three identifiers are reserved as predefined literals in the language. Okay, these are the three predefined literals: null, true, and false. What are literals? That we will understand later towards the end of the session. Okay, so these three are the literals that are defined in the language. Okay, so actually these slide materials, these PPTs and presentations are provided by Capgemini, and sometimes they are outdated also. That's why the table which has been shown here is available in Java 5. Okay, now we have 17 versions of Java, like till Java 17 we have, and specifically in this session we will be discussing Java 8. So this table might vary. Okay.
Okay.
Okay. So here you can see only 50 words are there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 50 words in this table. Okay. This is Java 5 table. So these numbers can vary, and I'm telling you the latest number, that is 52. So now if you are appearing for interview in this year, then you have to say 52 total keywords. Clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So now let's move on to the next topic, that is data types used in Java. So just observe this table for 1 minute and then we will start. How many data types can you see in the table?
8.
8.
So we have eight primitive data types in the Java programming language, and the table shows that every data type, every primitive data type is having some size associated with it, okay, and it is also having some range associated with it. Some size and some range associated with every data type which is present in the Java language. Okay, so now I will dictate some statements. Please note it down in your notebooks. Put the heading data types. Put a heading data types. So the first statement is Java language is a strongly typed programming language. Let me write in the chat box. Java language is a strongly typed language. Can you see in the chat box? Strongly typed language. Java language is a strongly typed language. Point number 2. Are you writing?
Yes, ma'am.
Yes. For first statement, Java language is a strongly typed programming language. Second statement, every data and expression, every data and expression in Java, every data and expression in Java have some data type. Have some data type. Third statement, every data type has some size and range. Every data type has some size and range. How many points done?
3 points.
3 points.
3, ma'am.
Next point. Every data type has some default value. Every data type has some default value. Last point. Compiler is responsible for checking type compatibility. Compiler is responsible for checking type compatibility. Is it clear?
Yes, ma'am.
Okay. Let me download one image where we have range also. In this material, they have not provided the range. Please read out all the points one more time. Whatever 4-5 points we have written, read it out. Very important. Any doubt in any of the point? So what do you understand by strongly typed? Does it mean that I have to hit the key in the keyboard very hard? That does it mean strongly typed? If we press the key very hard with lots of force,
No.
then what is strongly typed? Hmm? Strongly typed means each and every data that we are using in the Java program has to be declared with some data type. Like for example, if you are using any variable, A, B, C, D, X, Y, Z, pi, or small g, any type of variable that you are using in Java programming language, it has to be declared with some data type. That is what means strongly typed. Why? Because you can see the second last point, compiler is going to check for the type compatibility. So every time you are not declaring anything, compiler is going to throw the error. You will get compile time error because compiler is responsible for checking everything related to data types. So if you have not declared anything properly with the appropriate data type, or there is an expression for which type compatibility is mismatching, in that case, compiler is going to tell you with some compile time error. We will see in the program. Now, can you see the screen? We have at one side all the primitive data types. In the middle column, we have the size associated with each of the data type. And in the third column, I have kept the range of each and every data type. Okay. So one by one, just go through this range. I will tell you how this range has been derived. Second thing, you don't have to remember each and every, range, because that is not required. Like this is okay, this is okay, this is okay, you can remember. This how we got, I will tell you. Now all these things you don't have to remember. Actually, they won't be asking you in the interview room, but you should know how we got this range. Okay, so there is some relationship between the size and the range of any data type, because with this size only you can derive the range. Let's understand that. Before that, see, I have kept all the 8 data types in front of you, but how these data types have been classified, let's understand with a diagram. Okay, so instead of using marker there, I will tell you here only. We have something called primitive data types. You can draw this diagram in your notebooks also. Give me 1 minute, my system got hanged. So we have primitive data types. Okay. Now inside primitive data types, we have some classification. What are those classification? Two types of primitive data types we have. One is numeric and one is non-numeric. I am telling you so that you will remember it properly. So one is numeric and the other one is non-numeric. Do you understand the meaning of numeric and non-numeric? In numeric, we can store all the number integral data. Okay, integral data that is related to numbers. In non-numeric, we can store data that is characters or Boolean, such kind of data. So anything related to numbers can be kept in this category, numeric. Anything related to characters or true or false can be kept in non-numeric data. Is it clear?
Yes.
Yes.
Then let's move forward with numeric data type. Okay, so inside numeric data type, we have first one is integral. And then we have non-integral. Or we can say floating point. Okay, inside numeric, two types of numbers are there. Integral, okay, integer type, integral, and one is floating type. And non-numeric side, we have again two types. One is character and one is Boolean. Okay, one is character, one is Boolean. So numeric is integral and floating. Non-numeric is character and Boolean. Now, inside integral, we will see what different types of data types we are having. So inside integral, the first one that we have is called as byte data type. Second that we have is short data type. Then we have int data type. And then we have long data type. Okay. So first of all, we have something called primitive data types in Java. The primitive data types have been classified as numeric and non-numeric, okay, based on what type of data you want to use in the program. Now, if I want to store some numeric values, then numeric values can also be classified as integral and floating. So if it is an integral value, that means it is a discrete value. Integral, what is the difference between integral and floating point? If I say 5, 10, 500, 10,000, that is an integral value. It's a discrete value. We don't have any decimal values inside it. But if I say floating point number, that will be having some decimal number. For example, 4.5, 3.14, 5.6, 5.89852. All these will be floating point. They are not discrete numbers. Now, inside the integral values, you can use these four data types for storing the integral value types: byte, short, int, and long. You should know the classification in this way. Then only you will be comfortable and you can predict the compiler error also. Sometimes if the question comes in the form of errors, then also you will be able to answer. Now inside floating point, we have two data types. One is float and the other one is double. Inside char and Boolean, we don't have any classification. It is already classified in that way. Okay, so can you see this diagram? Draw this classification tree in your notebook. Primitive data types. Then primitive has been classified to numeric and non-numeric. Numeric has been classified to integral and floating. Integral is classified into four types: byte, short, int, long. And floating is classified into two: float and double. Then here we have non-numeric data types having char and Boolean. So how many data types we have? 1, 2, 3, 4, 5, 6, 7, and 8. The 8 primitive data types that I showed you in that document, I have shown you how it has been classified. So if you want to declare any discrete value, any discrete number which is not having any decimal values, then we will go for these data types. Every data type will have its own range. Depending upon the range, we can pick any data type. Then if we want to store some numbers with decimal values, we can opt for these data types. If I want to store some characters, or I want to store information in any language like Hindi, Marathi, Telugu, Tamil, all this facility is there in char data type. And if I want to store true and false values, information about logic gate truth table, all those things, then I can go for Boolean. Any doubt in this diagram?
No, ma'am. No, ma'am.
Very good. Just draw this classification tree in your table. As I don't have marker and board, I am using paint, but you can, draw nicely. So let us discuss one by one what is the range and how we can derive that range based on the number of bits we are using for representing any data type. Is it done?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So let's one more thing. All the numeric types, okay, all the numeric data types are signed numbers. Okay, they are signed data types. That means you can represent the numeric data type as positive as well as negative. All the non-numeric data types are unsigned. Okay, this is understood. Because character and Boolean cannot be negative. Okay, it cannot be true and false cannot be negative. So this numeric is signed and non-numeric is unsigned data types. Any doubt in this?
No, ma'am.
No, ma'am.
No, ma'am.
Very good.
No, ma'am.
Very good. So let's proceed. So byte can be represented. First, we will discuss about byte. Okay, so byte data type can be represented using 8 bits. That means 1 byte is required for representing a byte data type. So if you see the classification tree just now that I drawn for you, you can see that all the 8 primitive data types I have listed in that classification tree. Now, if I am using 8 bits for representing any number, then what would be the range of that number? Let's calculate the range of byte. So byte data type is used for storing the integral numeric values. Now, can you relate through the diagram that you have drawn that byte is a number which can be integral? Okay, so if you want to represent any integral numeric value, you can opt for byte data type. You can see from your classification tree. Now let's understand, if we have a byte data type, how many numbers we can represent. So what is the size of byte?
8 bits.
8 bits. So we will be having 8 bits. Now I told you that byte is a signed number. That means we will use 1 bit for representing the sign. This will be called as the sign bit. Am I clear?
Yes, ma'am.
So if the sign bit is 0, that means it is a positive number. And if the sign bit is 1, that means it is a negative number. Now we are using 8 bits for representing a byte data type. Out of this 8 bits, 1 bit I am using for representing the sign bit. Then how many bits are left?
7.
So we are left with 7 bits. Okay. Now can you tell me the maximum number that is possible using 7 bits? What is the maximum value which we can represent using 7 bits? Yes, tell me. 1, 2, 3, 4, 5, 6, and 7. So the maximum number that we can represent with 7 bits will be 1, 1, 1, 1, 1, 1, 1. 1, 2, 3, 4, 5, 6, 7. If I set all the 7 bits as 1, then it will be the maximum positive number that is possible using 7 bits. Now, how to calculate the decimal value? 2 to the power 0 into 1 for this place. Then 2 to the power 1 into 1 for this place. Then here 2 to the power 2 into 1. Here what will be the value? 2 to the power 3 into 1. Here 2 to the power 4 into 1. 2 to the power 5 into 1. And here 2 to the power 6 into 1. Can anybody tell me the decimal value for this?
127.
127. Yes, very good. So the maximum number which is possible is 127. And what is the minimum number that is possible? So minimum number will be some
minus 127.
minimum number will be a number which is a negative number because this is a signed data type. Okay, minimum number will be a number which is a negative number because byte is a signed data type. So how do we represent negative numbers in system? Can anybody tell me? If you remember anything from your digital logic classes.
Minus 126.
No, I am asking
1,
how do we represent negative numbers in computers?
1,
By 1.
No, we represent negative computers by using 2's complement. We represent negative numbers using 2's complement. So the negative number which can be represented with this 7 bits is minus 128. Okay, if you take the 2's complement of minus 128, then that is the minimum value which we can represent using these 7 bits. Okay, so 1 bit we are using for sign representation. Other 7 bits we are using for representing the data, and maximum number that we can represent using the 7 bits is 127. Minimum number that we can represent using these 7 bits is minus 128. So this is the range of byte data type. What is the range of byte data type? Minus 128 to plus 127. Minus 128 to plus 127. Clear? Now, if this is the range, then if I try to represent anything out of this range, what would be the error that I will get? Let's understand. So I have a data type byte and I want to declare one variable. Let's say var. Var is the name of my variable. And I want to give the value 139. So 139, is it allowed value?
No.
No, ma'am.
Because it is not falling in the range of byte. So let's try to run this program. So what is the type? What is the error? We got an error type mismatch because I told you the compiler will check for type checking. So compiler will throw the error. So what compiler is saying, there is a type mismatch, cannot convert from int to byte. Cannot convert from int to byte. That means this number is integer value and you are trying to convert it into byte. If I write byte b is equal to 10, byte var is equal to 10. Now it is correct or not?
Yes,
Correct.
ma'am.
Yes, ma'am.
Because
Yes, ma'am.
this 10 is falling in the range. So you can see that the program has been compiled successfully. So whenever you want to declare any variable with byte data type, those who are coming from different branch, what you have to do is you have to specify the data type. For example, the data type we are discussing here is byte. Then you have to give some name to your variable. So I have given the name var and I am specifying some value. This value should fall in the range specified by this data type. If it falls in the same range, then the program will compile. If it won't, then we will get the error type mismatch. Is it clear? Again,
Yes.
Yes, ma'am.
if I give 128, what do you say? What will happen?
Error.
Again, I will get a
Error, ma'am.
compile time error and I will get an error type mismatch. Now, I told you that character and Boolean are unsigned. Okay, so definitely we don't have any signs associated with char and Boolean. Please, whenever I am saying any data type, see the diagram that you have drawn in your notebook. So if I write char ch is equal to a, char ch is equal to a. Is it right or wrong?
Right, ma'am.
Right, ma'am.
Right, ma'am.
But if I say minus a,
It's wrong, ma'am.
No, ma'am.
Character is
then it
Unsigned.
is wrong because it
non-negative
cannot be
character.
signed. Because non-numeric data types that is there in the classification tree, char and Boolean are unsigned. Same goes for Boolean. If I have a Boolean data type b minus true, is it correct?
Yes, ma'am.
No, ma'am.
No.
No, ma'am.
False.
Again, the operator minus is undefined for the argument type Boolean. Okay, we cannot write minus true, minus false, true, false. This is not allowed. So for char and Boolean, you don't have to use sign values. Okay, they are unsigned. So now is it clear how we got this range minus 128 to 127?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
One more I'll show you. If I write byte b is equal to Avantika, then what will happen?
Error, ma'am.
Error, ma'am.
Error.
Cannot convert from string to byte because Avantika is a string. And string again is not a primitive data type. Okay, the primitive data types are only these 8 data types. String is not a primitive data type. Okay, string is a separate class in Java. Character is a primitive data type, but string is not a primitive data type. Is it clear to everyone?
Yes.
Ma'am.
Yes, ma'am.
Yes, ma'am.
So when do we use byte data type? Whenever you want to handle data in the form of streams. Okay, for example, file handling. Okay, if you know file handling, then it is a file supported and network supported data type. In file handling, in network, when we are communicating with each other, everything is flowing in the form of streams of data. We have input stream of data, we have output stream of data. So everything is flowing in the stream of data. Stream of data means we have a sequence of bits which is flowing from sender to receiver in network. So whenever you are handling data in the form of streams, then you have to use byte data type. You can note down in your notebook that if you want to handle data in the form of streams, then you can use byte data type. It is file supported and network supported data type. Am I clear? Whenever you are handling data in the form of streams, in that case, you should opt for byte data type. Is it clear? Shall we proceed with next data type?
मैम
Yes, ma'am.
रिपीट कर सकते हो?
Which point should I repeat?
बाइट में यूज कर कैसे यूज कर सकते हो?
Acha. See, we have, if you see the classification tree, we have so many data types for representing numeric data. Okay. So when should we decide that when to use which type of data type? Okay. So we should be clear then that in which situation we have to go for which type of data. For example, if I ask you how much time light will take to travel from sun to earth? How much time light rays will take to travel from sun to earth? So this will be a very big number, right?
Yes.
So it is such a big number that we cannot represent this large number using byte data type or short data type or int data type. So in that case, we will go for long data type. If we want to store such large numbers, then we should go for long data type. Similarly, when should we go for byte data type? When it is useful. So byte data type is useful when you are handling the data in the form of data streams. Data streams means when you are handling the data in the form of sequence of bits. So when you are working on network, okay, some network programming you are doing, or you are working with file handling. In that situation, we use streams of data. So in that case, you can use byte data type.
Okay.
Okay. And if I ask you, what is the distance between moon and earth? What is the distance between Pluto and earth? For such things, you cannot use byte, short, int. Okay, these are very big numbers. Then we will use long data type. Is it clear to everyone?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So what is the default value of byte? So you can see the default value of byte, third row, default value is 0. Default value is 0. So if you don't declare anything, you don't initialize the variable, it will hold 0 value. That is also an interview question. Default value of this data type, default value of that data type. So just keep this table in mind. Next, let's move on to short. Please see your classification tree. I will discuss in the order of the classification tree. What is the next data type?
Short data type.
Short data type.
Okay, short data type. So now what happens? See, you can see here, short data type is having the default value 0 and its size is 2 bytes. So 2 bytes means how many bits?
16.
16 bits. Okay. So if I have a data type with 16 bits and it is a signed number, then 1 bit we will keep for representing sign. If it is a positive number, then 0. If it is a negative number, then 1. So this is my sign bit. The most significant bit is my sign bit. Other than sign bit, how many bits are left for representation?
15.
15.
So out of 16, 1 bit is used for sign representation. Now we are left with 15 numbers only. Okay. So with these 15 numbers, how to decide the range? So there is one technique which you can apply for byte data type also. Let me write it with a colored pen and you remember it also. Okay. So with with 15 bits, the minimum and maximum number that we can represent is minus 2 to the power 15 to 2 to the power 15 minus 1. Why we are doing this minus 1? Because 0 is also included. Okay. If we start from this number and we end on this number, in between the number x's, 0 will also be there. So if we are counting 0, we have to subtract one number from here. So if you have 15 bits, so with the 15 bits, the smallest number that we can represent is minus 2 to the power 15. And the largest number that we can represent is 2 to the power 15 minus 1. Is it clear to all of you?
Yes.
So you can calculate it, which is not required actually. Okay, they won't be asking you such questions in the interview. What is the range and all those things are not required. But if you calculate it, you can get the range of the short data type. Same way, you can calculate the range for byte also. How many bits we were having in byte data type to represent the data?
1. 8 bits.
8 bits.
8 bits we were having, but 1 we were using for sign representation. No?
7.
7.
7.
So you can use the same technique for checking whether this is working or not. Okay, don't forget this minus also. Next, is it done? Now the question comes, when should we use short data type? Because usually you see whenever we write any program, directly we are using int A is equal to 10, int B is equal to 30, int B is equal to 400. We hardly use, short data type. Do you use short data type whenever you program in your college time? Do you ever use short data type?
No.
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 So
ma'am.
actually, short has become a very rarely used data type. So why is it so? Can anybody tell me? So when Java was introduced, I told you in the history of Java. When Java language was introduced?
1995.
Yes, in the early 1990s. Okay. So what happened in early 1990s? What type of processors we were using? Like these days we are using, i5, i7, i3 second, all these processors. That time what processors we were using? We were using 8085 processor. We were using 8086 microprocessor. Have you studied these processors in your BTech?
Yes.
8085, 8086, my
Yes.
God,
Yes.
very dirty
8086
topic.
microprocessor.
Yes. It's very dirty, na? Complete pin diagram you have to remember, and it comes in exams also.
Yes, ma'am.
Architecture.
Yes. I used to hate it when I was a student. So 8085, 8086 microprocessors were used at that time, and they all were 16-bit processors. Okay, they all were 16-bit processors. And short is a 16-bit data type. So if the processor is 16-bit, that means read and write operation will become very efficient because the instruction length will be 16 bits and the data we are storing using short data type is also 16 bits. Are you getting my point? We are using microprocessors with 16-bit size. So the instruction length will be 16-bit in the microprocessor and the data we are storing is also 16 bits. It's short data type. So the read and write operations will become very fast. Okay, so that time we were using short data type. But now look at your laptops. What is the size of processor now? 64-bit, 32-bit. No one is using less than 32-bit processor at present. Okay, my laptop is 64-bit. Most of your laptops will also be 64 bits. Or some of you might be having 32-bit processors. So that is the reason why Now we are using int. See what is the size of int? 4 bytes. 4 bytes means 32 bits. Okay. So we are using int, we are using long because our processors are now 32-bit and 64-bit processors. But in the early 1990s, we were using 16-bit processors. So that is the reason why short is very rarely used these days. Is it clear?
Yes.
Okay. So how to use short data type? That's very easy. You already know. We will write short keyword. Okay. Short S is equal to 32767 because this is the maximum number that we can represent using short. So the range of short data type is minus 32768 to plus 32767. So is this number allowed? Sorry, I kept colon. I have to keep semicolon. So this number is allowed because it is in the range. See, my program is compiled. If I want to print this value, I can print also. System.out.println. How I am creating a class, how I am writing main method, this I will discuss in tomorrow's session. So those who are not understanding how we have written methods, main methods and all those things, don't worry. Tomorrow we will discuss. There is no problem because 32767 is the maximum number that we can represent using short. But if I write, then what will happen? Compiler will give
error.
Compile time error, type mismatch, cannot convert from int to short. So it is considering, compiler is considering it integer value. And we have declared it as short. So it is not acceptable. Okay. Short is the integral value or floating point value?
Integral.
Integral.
So
Integral.
let's try to store something in floating. Then what error it should give? Cannot convert from double to short. Again, type mismatch. Okay. So this type of, why I'm showing you these errors is because if you get such errors, you know where is the problem. And also I want to tell you that compiler is responsible for checking the type compatibility. Okay. Compiler is doing everything. Clear?
Yes, ma'am.
Yes.
Now let's move on to the next data type. Please see the classification tree. Which data type we have next?
Long.
Int.
Int.
Int data type.
Int.
So int data type is integer data type, which is very commonly used data type. Okay, very commonly used. What is the size? Let's see in the table. Please remember the size of the data types. Okay, that is very much
16
important.
bit.
So who said 16 bits?
4 byte.
It's okay.
32.
32.
Integer is 32-bit data type. Okay. So if I say integer requires 32 bits for representation, quickly you calculate the range in your notebooks and tell me what is the range. Now you know now how to calculate range. All of you quickly do that.
Minus the 2 raised to 3 1. 2 3 raised to 3 1 minus 1.
You can say 31 now. 2 to the power 31 you can say now. So I will be using 32 bits for representing a integer number. Okay, like this. Okay, and most significant bit Which one? Most significant bit will be my sign bit. Again, I don't need to discuss what is sign bit. Now, out of 32 bits, 1 bit I am using for sign representation. How many bits I am left with?
31.
31.
31.
Okay, this is one. This is one. Okay. So the range is minus 2 to the power 31 to plus 2 to the power 31 minus 1. Okay. This is how we can remember the range. Now, if you will remember that range, now the exact range, then it is. See, I have written in some notebook. I also don't remember. Minus 21474836648 2 plus 21474836647. That is not required in interview. Don't waste your time in learning all these things. Okay, just remember this logic. 1 bit we are representing for sign. So the range is minus 2 to the power 31 to 2 to the power 31 minus 1. This you can remember because this you have derived. This you know how it has been derived. Okay. So integer data type is used for storing the integral values. The range is from minus 2 to the power 31 to 2 to the power 31 minus 1. And we can store both positive as well as negative numbers using this data type. Okay, no questions, I think. Okay, so let's say, let me tell you, if I want to store, okay, modify here. If I am declaring int data type with a value range 2147 483 483 648 648. So will I get error?
No.
I will get, because the range is still 47, but I am declaring a value which is out of the range. So what it is showing? The literal of type int is out of range. Okay. So this is how we should follow the range. If I write int x, int s is equal to true. So I am giving a Boolean value to an integer data type. So again, type mismatch cannot convert from Boolean to int. Clear?
Yes, ma'am.
Okay. Next data type which we have. Are you noting down everything in your notebooks?
Yes, ma'am.
One day I'll make you people turn your camera on and show your notebooks. This I am going to do soon.
Okay,
So next data type we have in the classification tree as long. Okay, we have long data type. So again, I told you there are certain things related to this universe that are very large. For example, amount of distance the light has traveled, speed at which the light is traveling, distance between Mars and Jupiter, distance between this and that, all those things. Okay, solar system things. Or if I have a ebook, okay, if I have a ebook and I want to calculate the number of words present in that book, or I want to calculate the number of characters present in that book. So if it is a very huge file, ebooks are, very huge in size. If you want to calculate the number of characters present in any ebook, then we can use a length function. We have a length function in Java, inbuilt function, length. Okay, length method is there. So for such things, integer is sufficient.
No, ma'am.
No.
No, ma'am.
No.
No, ma'am.
So for such thing, integer is not sufficient. So that is the reason why we have long. Okay, long is having size of 8 bytes and the default value is 0. So if 8 bytes means 64 bits. Okay. Quickly tell me the range of
minus 2 raised to 63 to 2 raised to 63 minus 1.
Very good. Okay. So do I need to write it here? Let
No.
me write because some students are not from computer background now, so they have not done digital logic things. So they should also know. So students, we have long data type. So in long data type, we will be having 64 bits. Okay, we will be having 64 bits. Like this 1, 2, 3, 4, 5, 6, 7 up to 64 bits. Out of these 64 bits, we will use 1 bit for the sign representation, plus number or minus number, positive number or negative number. And how many bits I am left with? I am left with 63 bits. Out of 64, I am using one most significant bit for sign representation, and I am left with 63 bits. So these 63 bits can be used for data representation. So if in computer science, everything is presented in the form of zeros and ones. So if you are given 63 bits, there is a possibility that with this 63 bit, you can represent a minimum number, and the value of the minimum number is minus 2 to the power 63. And the maximum number that you can represent with the 63 bit is 2 to the power 63 minus 1. See, my handwriting is not that poor, but because of this paint, it is looking poor. Clear?
Yes, ma'am.
Okay.
Ma'am, you can try using Microsoft Whiteboard, no? That's much easier.
In that also brushes and all these things are there, no?
Yeah, you have all the significant tools what you need.
That are also these same tools, brushes, this pencil. Okay, I'll try doing that. Okay. Then time is 6:21. I want to start floating point now, but it won't be over. Okay, let us complete char and Boolean. Okay, float and double we can discuss in the next class. So char is very much clear. How much space char is using?
2 byte.
4 bytes.
Where is this PPT? So character is using 2 bytes. So 2 bytes means we have 16 bits.
16 bits.
Okay. So if it is 16 bits, then it is unsigned also. We are not going to reserve any bit for representing any symbol, sign, plus or minus. So with the 16 bits, how many positive numbers you can represent? Tell me.
8.
What are you saying?
0,
All 16.
See, we have 16.
0 positive, ma'am. No sign will be there.
No, you are not understanding. Right.
256.
No.
234.
No.
65.
Okay. Yes. 65536 characters. Someone said it right. Okay. So with 16 bits, okay, we are using 16 bits, and all the 16 bits we are using for representing only positive numbers. We are not going below 0. Okay. So with 16 bits, we can represent total 65536 characters. 65,536 characters. Okay. Can you tell me how many bits we were using in C++ for character?
1 byte.
1 byte we were using. Okay. 8 bits we were using. So when we were using 8 bits, let me use the marker again. So when we were in C++, we were having 8 bits for char. In Java, we are having 16 bits for representing characters. So with 8 bits, again, you can draw that diagram and understand, okay? 8 bits means 1, 2, 3, 4, 5, 6, 7. And how we can calculate the values? 2 to the power 0 into 1. Then 2 to the power 1 into 1. Like that, we will go to 2 to the power 8 into 1. Okay, like this. So we can represent 256 characters. In C++, we were having 256 characters to be represented, to be used in C++. Okay, so actually C++ was using ASCII code. Okay, ASCII code for characters. So in ASCII code, we were having 256 characters in C++. Now what happens in Java is we are using Unicode based system. Please note down in your notebook. In C++ and C language, we were using ASCII based code. But let me write in chat box, else you will note down incorrect spelling. In C++ and Java, we were using ASCII code. Please see the chat box. And in Java, we are using Unicode based system. So in Unicode based system, please see the chat box. Okay. So if I am using ASCII based system, I can represent 256 characters. If I am using Unicode based system, then I can represent 6, 5, 5, 3, 6 characters. Okay, obviously, because here we are using 16 bits and there we were using 8 bits. So definitely we can use more number of characters in Java. Okay, so in C++, you don't have like Marathi characters are not there, Telugu characters are not there, Malayalam characters are not there, Hindi characters are not there, but it is there in Java. Okay, in Java, in the 65536 characters, you can print English, Hindi, Malayalam, Marathi, and everything. Okay, so 65536 characters we can represent, but the range is starting from 0. So the range of character is 0 to 65536. Is it clear?
5.
Sorry, 555. 0 to 65535 because we are starting with 0. Any doubts so far?
No.
Okay. Now the question comes, what is the default value of character? So some of you will say null, but that is not correct. In interview room, they will ask you, what is the default value of a character? So default value of character is this. Okay, it's not null. In Java, null is the default value for an object. Okay, if someone will ask you what is the default value for object, then you have to say null. But for character, it's not null. Clear?
Yes.
Yes, ma'am.
Okay. Then after char, we have Boolean. Okay. So here you see, where is Boolean? Just In the first row, you see what is the size of Boolean? 1 bit.
1 bit.
But that is not correct. Okay. Actually, the size of Boolean depends upon the virtual machine. It is virtual machine dependent. Please note it down in your notebooks. Size for Boolean is not applicable. It is virtual machine dependent. So why they have written 1? Because in general, what we do, Boolean can accept two values, true and false. So what they try to do is, they try to represent 1 as true and 0 as false. And that's why they have written 1 bit. But in some cases, you will see the size of Boolean is 2 bytes. Okay, so size of the Boolean is dependent upon the virtual machine that you are using. It's not fixed. Okay, so if someone will come to the interview room, they will say, size of Boolean is 1 bit. Someone will answer 2 bytes, but you will be there to answer that for Boolean data type, size is not applicable, range is not applicable. It allows two values, true and false, and the size is virtual machine dependent. Okay, then who will get selected? You or that other candidate?
Us.
We.
Yes, you will get selected. If I write Boolean B is equal to true, is it correct?
Yes.
No, it's not correct. Okay, it has to be small t. Okay, so you have to write true or false. It's a case sensitive language. Okay, you have to write in small letters, true or false. Clear? Again, you don't have to use double quotes also. Don't think like true is a string, so we should keep in double quotes. You don't have to. Directly you have to write true and false in small characters. Okay? Clear?
Yes, ma'am.
I repeat the question. The question that will come from this topic is, what is the size of Boolean? So you have to say size is not applicable for Boolean data type. It is virtual machine dependent. Next, let's discuss float and double also. For 5 minutes, the class will extend, but this topic will get over. So float and double, let's see. Both are similar actually. The difference is only what is the difference between int and long. So the difference is only in the range. Okay, int and long both are used for representing numbers. Similarly, float and double both are used for representing floating point numbers. But if you want floating point numbers to be represented to 5 to 6 accuracy, let me tell you in the paint. Are you tired?
No, ma'am.
No, ma'am.
Give me 5 minutes, okay? Actually, in the beginning, I started discussing about qualifying students, so I got late. So if I write 7.783, 7.7854. So this number we are taking only up to 5 to 6 accuracy. Okay. So for this kind of numbers, we can use float data type. But if I want to store a number with like 89.7356, it's just, I'm not telling the number, just look at the window. Okay, if I want to store such numbers which is having 14 to 15 digits of accuracy, they are called as double precision. So in that case, we have to use double data type. Okay, so size of float data type is 4, and please note down in your notebooks. Size of float data type is 4 bytes, and it is used for representing numbers up to 5 to 6 accuracy. And it is called as single precision. But double, yes.
Could you repeat once?
You are noting it down?
Yeah.
Okay. So please note down. Float data type is used for single precision representation.
Precision.
Precision. Precision. Single precision. That means we can represent numbers up to 5 to 6 accuracy. We can represent the numbers up to 5 or 6 accuracy. Next point. Double data type is used for double precision representation. Double data type is used for double precision representation. That means we can represent a floating point number up to 14 to 15 accuracy. A floating point number up to 14 to 15 accuracy. Okay. Size is 32-bit for float and 64-bit for double. Please mute yourselves. Okay, so let me tell you the range also. Okay, I'm telling you the range also for these numbers. As these are floating point numbers, so we can represent floating point numbers with these two data types. So for float, we have the range starting from -3.4 into 10 to the power 38. Maybe I am not updated. Okay, you can cross check also. Up to plus 3.4. Plus 3.4 into 10 to the power 38. Okay, this is the range for float data type. For double, what is the range? Minus 1.7 into 10 to the power 308. Okay, because we are using 14 to 15 accuracy. Okay, so the range has to be large. Up to 1.7 into 10 to the power 308. Okay, you can once you cross check also. Okay, maybe my record is not updated. So this is how we can represent floating point numbers